Hello Year 11 and welcome to the fourth video here. For our third topic we have been learning about interest and depreciation, and so far simple interest. I did hint there was another way of calculating this, and the other common way of calculating your interest is compound interest. Now bear with me here. With compound interest, every time interest is calculated, let's say at the end of the year or the month or whatever, every time they calculate how much interest you've earned, right, the interest that you've earned gets added onto the principal. So that next time when they calculate how much interest you need to be paid, it's calculated not just on the original principal, but also on any interest that you've earned up to that point. So what happens is over time, the interest starts to grow faster and faster. Now, we have a formula here and some important distinctions between this formula and this simple interest formula. There are some similarities, but there are important distinctions. First of all, is that this calculates the final value of the investment. Final amount, A for amount, that's what you will have in the savings account once we have finished with all the calculations. Simple interest doesn't do that. Simple interest tells you how much it increased. This tells you how much you've got. P is the principal, same as before. Now, this, don't confuse it with an L or anything like that. It's just a number 1. It's 1 plus the interest rate. And if you go right back to the very first question that we did in this unit, was to increase something by a certain percent. Right, if I wanted to increase, I think it was $450 by 20%, we multiplied by 1.2. Right, that was the 100%, the original amount, plus the 20%. So we didn't calculate 20% and then add it on. Right, we added 20% to 100% and found 120% of the original amount. Really, a very similar thing happens here. That's why we have 1 plus R. Okay. So that we find out not how much interest we're earning, but how much I'll have at the end. So it's 1 plus R. It's not multiplied by n, but to the power of n. Right, power of n, and n is the number of compounding periods. Again, like simple interest, and more importantly here, while the interest rate might be quoted per annum, might say compounding monthly, in which case I have to divide my interest rate by 12 to get a monthly interest rate, and I need to calculate how many months, being the compound periods, right, to put how many months up here where n is. That's very important. So let's jump into an example now. I have $12,500 invested at 4.8% per annum. Interest compounded monthly, right? Compounded, right? Compounded tells me I've got to use compound interest formula, simple interest. And monthly means that I need an interest rate per month, and I need to know how many months it's invested for. So 4.8% is going to be 0.048 over 12. Right, I'm going to write that in straight away, so that it reminds me not to skip past it. Now that's my principal, that's good. Calculate the final value, that's good. And total interest. Right, we'll have to get to that as the second part, over 2 years. Now 2 years, monthly, right, means that that's 24 months. If we use 4.8% and 2 years, we'll get a different answer. A slightly smaller answer. Anyhow, my A, my final amount, is equal to my principal, 12,500, multiplied by 1 plus 0.048 over 12 to the power of 24. Calculator comes out. Turn it on, drag it out of the road, and I have 12,500 multiplied by bracket fraction. Here we go. Oh, no. Come out here. 1 plus my fraction. Oops, should have done that to begin with. No, here we go. 0.048. Now that's our 4.8% divided by 100 to make it a decimal. and it's got to be divided by 12 to make it a monthly figure. Close my bracket, and it's to the power of, right, that's using this x to the y button here, to the power of 24, because there are 24 months in 2 years, equals 13,756.85. 13,756.85. Here we go, 85. And a little bit of common sense here. We have a look. Started with 12,500, ended up with a little bit more. So that's good. That is my final value, done. The interest earned, right, my interest is going to be the amount minus the principal. Okay. What I finished with minus what I started with is how much it increased. Right, so that's equal to, oh, my pen's failed on me. Everything's failed on me. Hang on. Okay, that equals 13,756.85 minus 12,500. And let's suppose we can do this without a calculator, and we see that it's $1,256.85 is the interest earned. Okay, so those are the two parts of my answer. Now, moving on to our second example for this exercise. What present value, right, so that's P, that I don't know, 4.5, oh, there's a percentage missing there, 4.5%, 4.55%, geez, actually, I think what's happening there, no, that should be, right, that's a typo there, it should be 4.5%. Okay, remember having a look, percentage button's above the 5, that's what's gone wrong. 4.5% per annum for 8 years. Now there's no hint of months or quarters or half years or anything, so that's good. I can say that R equals 0.045 per annum. And N equals 8. Right. A equals 10,000. So this is pretty good. Nothing overly complex here. We do have to work backwards. So we write out our formula, replacing, right, in the formula anything that we know already. So instead of A, I'll say 10,000. Instead of, oh, I don't know P, so I've got to put that there. But it's P times 1 plus 0.045 to the power of 8. Now I'm just going to tidy this up a little bit and say $10,000 equals P times 1.045 to the 8. Right. It's really easy to do that addition. Certainly makes things a little neater. Now a bit of algebra. Divide both sides by 1.045 to the power of 8, and I get P is equal to 10,000 divided by, or over, 1.045 to the power of 8, and I will most certainly need my calculator there. So we've got 10,000, I can use my fraction button here, 10,000 over 1.045 to the power of 8. Right, just having a look at the screen and what I've written down there. Right, matches up pretty well. Yep. And I'm expecting an answer that's a little bit less than $10,000, right? $7,031.85. $731.85. Okay. Wonderful. Well, that's it. Oh, no, wait, it's not it. Now, I have another question here. We've got a table. Now, people tend not to, students I should say, tend not to like using these tables. They change all the time. You can't just learn how this particular table works and expect them all to be the same. You've got to read it carefully, have a look and see what's going on. There will be enough information provided to work out what this particular table tells you. So, this tells me the compounded values of $1. It means that if I invest $1, right, it's going to tell me how much that's going to be worth after different lengths of time, earning different interest rates. These periods could be months, they could be years, they could be quarters, they could be half years, who knows? That doesn't matter as long as this interest rate corresponds to the same length of time. So first of all, the final balance when 2,000 is invested at 8% per annum, compounded annually for 6 years. So 8%, 6 years. There's nothing complicating the matter there with months or something. So $1 will become $1.59, for example, but it means that $2,000 will be 2,000 times that. So I'm going to say 2,000 times 1.5869. Here's my calculator. And I get 3,173.80. 3173.80. Okay, this first one, just check the final balance, right? I don't want the interest, I want the final balance. That's what I'm after there. You can see it's a little bit more than I started. For part B, the final balance again, that's good, that's A, when 14,000 is invested 7 months, 2% per month. 2%, 7 months, righto, and I get this one. So this time, 14,000, I'll put little dollar signs here, 14,000 times 1.1487, back to the calculator, 1.1487 equals $16,081.80. $16,081.80. Please forgive me any transcription errors when I flick back and forth between the calculator and the main screen here. So, is there anything else tricky going on there? No, not really. Now, C, the compounded interest. Different story between the final balance, or the final amount. Compound interest is the difference between what you start and what you end with. Right, so we're going to have a subtraction at the end. 9,600 invested at 10% per annum for 3 years, compounded half yearly. Right, that makes this 5% for 6 half years. Okay, so 5%, 6 half years. That's the one we're after. There's a bit of a clue there that there's no 10% column, right? If you get a question and you can't find the interest, you can't find the right column or row, then you're probably looking for the wrong thing. So, we've got 9,600 and this factor here. 9,600 times 1.3401. Right, when I do that, 9,600 times 1.3401, I get this, 12,864.96, 12,864.96, 64.96. Okay, but that is the final balance. I want to know how much interest was earned, so I need to subtract the 9,600. 864.96 minus the 9,600. This tells me by how much it grew. So there's my previous answer, minus the 9,600, and I get 3,264.96. 32, oops, 64.96. Interesting set of numbers there. But anyway, that's how much interest was earned. $3,264.96. Video's getting out of control now. That will do for compound interest, and we're really just about done for this topic. Any questions? You know what to do. Jot them down. See you in class.